Now, what we have next is two ships, X and Y, left the harbour 0 at the same time. X travelled north at 20 kilometers an hour, while Y travelled in direction north 6 degrees east. After 1 hour, Y was directly east of X. Calculate the distance travelled by Y. Once again, draw a little northeast, southwest triangle. They start off at a common point, which is this point here. Once you're finished with that, what we're going to do is we're going to draw in what ways the ships went. So the first ship went directly north, yeah, and it goes 20 kilometers north because it's traveling for 20 kilometers an hour, and it travels for 1 hour only. The next ship goes north 60 degrees east, so that's north, and then it goes east 60 degrees, and it ends up completely to the right of the last one. Where does it say that? Directly east of X. So that's X, that's Y. The green side is the distance travelled by X. The red side is the distance travelled by Y. And the black side is the distance between X and Y. Is that right? Now, what information do we know? That's 60 degrees. That's 20 kilometers. That's a right angle. And what are we looking to find first? Which is the red side. Hypotenuse. We want to find the hypotenuse using what information? Yeah, cos. Cos 60. 20 over h. And what happens to the h? H cos 60 equals 20. And then after that? 20 all over cos 60, which is? Anybody? 40. H equals 40. Now, H is clearly the biggest one in the triangle. It's 40. You have two choices to find out what this one here is. We'll use Pythagoras this time. 40 squared equals, we'll call it x. X squared plus 20 squared. 40 squared is 1,600. That is 400. Bring it over to the other side. 1,200 equals x squared. What's x then? Root 1,200? What? 34.6, which rounds up to 35. Did anybody do that a different way? Did anybody use tan to do that? You can use it doing tan as well. You can do tan to get that as well. Okay, moving on. Any questions on that, by the way? Before we go? Good. Right. So, not that button. Okay, same sort of question, except there's two different places. On leaving port P, the fishing boat sails in direction south, 30 degrees east. So it's currently here, and it's going down this direction here, and it travels for 3 hours at 10 kilometers. 3 hours at 10 kilometers is what? 30 kilometers. So it travels 30 kilometers in that direction there. What distance has the boat sailed? Okay, 30 kilometers. It's pretty easy. The boat next sails in the direction north 60 degrees east at 10 kilometers an hour until it is due east of the port. So it keeps sailing this direction at 10 kilometers an hour until it stops here, and it's at a level ground with the last one. Okay. What we need to find out is what are the angles involved here. Yeah, I just wanted one or two little tricks here, okay? If that's 30 and I continued this downwards, what would this be? 90 makes this one 60. 60. Because it has to add up to 180. Okay, and that makes this one 30. because that also has to add up to 90 degrees. Makes this angle in here 60 plus 30, 90. So this is 90 degrees. Okay. Now we also need something else. Can anybody tell me what angle this is up here? 60. Why? It's a right angle triangle. Oh, sorry, it's a right angle, not a it's a right angle, so it has to turn into 60. So basically, this question has turned into this. There's a right angle triangle. One of the angles is 90, the other one's 60. This is 30 kilometers. And what I want us to find out is how far the boat is from port P. So we want to find out what this distance here is, this red distance. Everybody see that? Is the red distance the hypotenuse, the opposite, or the adjacent of this triangle here? Yeah, the red one's the hypotenuse. It's opposite the 90 degrees. Okay, so we want to find out what the hypotenuse is, and we're using 60 degrees and 30 kilometers. So if we were to rotate this around a little bit into a more favorable looking triangle, that's what it'd look like, wouldn't it? That'd be 30 on the bottom, 60 on the bottom. That's a right angle, trying to find the hypotenuse, and that there is 30, and that there is 60. So what function are we going to use? Sine, cos, or tan? I'll read your odds. We're going to use cos. Cos what, guys? Yeah, equals 30 over h, and then after that? Yeah. Yeah, after that. And what you get? 60? Did you get that out? Good man. 60 kilometers. Write a note on the mathematical model used here. Do you think the length of the boat is important? Justify your answer. It can put off your answer by a small amount. So as an example, if you had we'll just draw a random bow here. Okay, and the person is in the middle. I say that it can put it off by a couple of meters. But because the distances are so vast, like you're talking 30 kilometers, being about 10-20 meters off. Huh? What you mean? Okay, so as an example, if we're undergoing this question again, except this time we're using a boat instead of a point mass, okay? When you come down here, is it the person has to hit the spot, or is it the front of the boat has to hit the spot? Then you turn around. So these things can introduce small errors. Like if your boat is like whatever 50 meters long, it can introduce errors of like 10-20 meters a turn. But what I'm trying to say, in comparison to 30 kilometers, what's 10 meters wrong? You know, it's pretty accurate in general. Yes, Lee.